Here's the formula, here's the data. Convert this to straight line form and find A and B. Predict T when such and such and such and such. Okay, so this is quite straightforward, isn't it? Y equals mx plus c. So we can see the correspondences for the components, can't we, for the straight line form. So we need to plot root q is our x, which is the square root of q. Then we plot y, which is equal to the square root of t. Then we can plot xy, and then we can mark off the x squareds. And then we can work out x bar and y bar and use our formula. Okay, so root q, so we need root 0.1, root 0.5, root 1 is 1, root 5 and root 10. Root 5 and root 10, and that's root q's data-wise. And then root t is root 12.1. Keep it in this form and it keeps it accurate. Root 14.97, square root of 17.32, 29.14 square rooted, and 40 square rooted. Okay, xy will just be these products, root 12.1 all the way down to, it's not the same, but you know what I mean. So, and then it's root 10 times root 40. So that table should be completed really, but I've just been a bit lazy. Then you've got this squared, which is nice because that's just 0.1, 0.5, 1, 5 and 10. And now we can do the summations, can't we? Okay, let's have a look at that then. So we got the square root of 0.1 plus square root of 0.5 plus square root 1 is 1 plus square root of 5 plus square root of 10. That's it, equals 7.42168, 7.42168, and so on. Okay, now we can multiply them, each constituent, by those products to get these products, isn't it? So let's do that. Times square root of 12.1 plus this times square root 14.797 plus 1 times the square root of 17.32 times 1 plus root 5 times root 29.14 outside the square root plus root 10 times root 40. So root 10 times the square root of 40 times root 10. So I think that's everything for the products. 40.06822, 40.06822, and so on. And then we can just delete the other square roots, can't we? So we can delete the root 10 part. And then we got the root 40, so that's okay. Then the 29.14, and delete the root 5. And then we've got root 17.32 times 1, which doesn't really matter. That's root 17.32. 14.97 times root 0.5. So let's get rid of that. Plus root 12.1 times root 0.1. Just get rid of that then. And that should be everything. Equals 23.23204. 23.23204. Okay, and then summation of the x squared 10, 15, 16.6. Okay, good. So what have we got then? We need y bar and x bar. So let me just get those. Well, I've got them there, haven't I? So it's 7.42168 over 5. Because there's 1, 2, 3, 4, 5 data points, and y bar is 23.23204 over 5 as well. So I'll keep them like that. Okay, and this is 5 times, so one of the 5's will cancel when we do the times in, so we just need to divide by 5 here. Summation of the xy's then. I'm just going to tap it in the calculator. So let's see what we get. Let's move this up just slightly so we got a bit more room. To there. Okay, so m equals xy, this one then, on the top, 40.06822 minus 5 times, but there's over 5 and over 5, so one of those will cancel, and there'll just be a 5 underneath, and there's the x and y values, isn't it? So it's 7.42168 times 23.23204. Now one of the 5's will cancel, so just divide by 1 5, close bracket, divided by summation of the x squareds, 16.6 divided by 16.6 minus 5 times x bar squared. Well, that would be this squared over 5 squared, and one of the 5's will cancel, so it would be just this over 5. It's this squared minus 7.42168 squared. One of the 5's will cancel, so we just divide by 5, because that's 5 as well. Close bracket. So I hope you can see that, and we get 1.0000. So m is equal to 1.0000. And that was to 3D. So C is equal to y bar minus mx bar. So it's just y bar minus x bar, because m is 1, so it's y bar 23.23204 divided by 5 minus 7.42168 divided by 5. 3.162 to 3dp. And that was to 3dp. So now our correspondences then. C equals A and M equals B. So C equals A. So A equals 3.162 and M equals B, so B equals 1. So what have we got then? Root T equals A 3.162 plus M, or B, 1 lot of root Q, wasn't it? There's our formula. Straight line approximation. Predict T when Q equals 7.5 was the question. Here. So T equals, well, the square root of T equals in the first instance 3.162 plus the square root of 7.5. So we can work out T, can't we, by squaring it. So we got the square root of that, which I'll leave in the calculator, plus root Q, square root of 7.5 equals, and then we need to square it, so it's answer squared, so ants squared. 20.4 is the temperature to 1 dp. 20.4. That's the stress, T. And now the other one from the formula. We need to, and Q when T is 13.5. So T equals 13.5. So square root of 13.5 is equal to 3.162 plus the square root of Q. So the square root of Q is equal to the square root of 13.5 minus 3.162. So Q will equal then. So we got square root of 13.5 minus 3.162. 3.162. 0.5, and then we do answer squared, don't we? To undo the square root. 0.262. And Q was the shear rate from the formula when T was 13.5. Now it's a 3D.